we're continuing with linear, only we're now moving on from linear equations, and we did linear inequalities. All right, so what we're moving on to now is we are now going to continue talking about, we started this last week, but we're going to continue talking about graphs of linear functions and linear functions in general, okay? So here's the deal. Graphs of linear functions. We talked about the other day, we talked about a few things, point, slope, form. We're going to talk about that again. But what I want to start with is what is the basic form of a line? And what is the slope-intercept form that we normally use? What's it called? Y equals? Right. So y equals mx plus b. All lines can be, all linear equations can be written like this. Remember the other day we did one of our examples was something like 2x minus 5 times x plus 1 equals 4 times x plus 2, let's say. Can we review, can y'all help me out? What can I do here to solve this? Distribute. Over here I'm going to distribute the 4, and I'm going to get 4x plus 2, right? Okay? And then what? Here I can distribute. So I'll have 2x, and then negative 5 distributes here and here, and I get negative 5x minus 5, right?
Yeah, wouldn't it be 8 instead of 2?
Oh, darn it, it's 2. Thank you. Man, so great. One of the reasons I love teaching in a classroom, I have thinking people that give me feedback. I love it. Yes, 4x plus 8. Thank you. All right, so now we can combine the 2x and the negative 5x into negative 3x minus 5 equals 4x plus 8. Now watch what I'm going to do here is I'm actually going to add 3x to both sides. Instead of moving this over here, that's going to eliminate the negative 3x. And it's going to give me negative 5 equals 7x plus 8. Now I could solve for x, but I'm going to stop. You know why? What do I have here now? I have a linear equation, right? I have something in y equals mx plus b form now, right? It's now if my y value is negative 5, right? So now what I could do is I could just change it up, and instead of making this a negative 5, make it a negative 6 or a negative 7 or something. But if I make this a negative 7, if I subtract 2 here, I have to subtract 2 over here, and then it would be negative 7 is equal to 7x plus 6. But I'm not going to do that right now. I just want you to see that linear equations can always be written in the y equals mx plus b form. Okay? All right? I'll wait. So now, what do we notice? What we've got now in a function, we always have two variables, not one variable. This is one of the biggest differences between a solvable equation and a function. All right? Let's look at this. This is a solvable equation. How many values can x take on here? How many values can x take on? How many answers are there for x? One answer. That's right. There is one answer for x. The number of answers, the maximum number of answers, is usually given by the power of the variable. Okay, so if this said x to the second power, it's called the fundamental theorem of algebra, something like that. Okay, and here's what it says is basically, well, one of the things it says is that whatever the power is on the x, that's how many answers you can have. Okay, so look, so there's only one answer here. But up here, if I choose numbers for this, what if I rewrote this with the 7 and the 8? What if I wrote it as y equals 7x plus 8? Now, how many possible combinations of x and y are there? How many possibilities? Multiple. That's a good start. What do you guys think? Give me a possible value for x. 1, okay? 15. 3, 29. What else? 10. Anything else? Any number. Or all real numbers. That's called the domain. The domain means how many different numbers can be plugged in, or which numbers can be plugged in. Well, we can plug any number in, right? Well, if we can plug any number in, then how many combinations are there? There are an infinite number of combinations. That's why our answer, that's why there's no answer to this. The only way to represent an answer to this is to draw a picture that shows all of the possible answers, all of the possible combinations. What's that called? What's it called when you draw a picture of all of the possible combinations? Let me show you what it looks like. It's a graph. That's what a graph is. A graph, so let's go to positive 8 here. Let's put a dot. I don't know if y'all remember how to draw these. It has a slope of 7, so it would look something like this. And this picture, this graph, is all, it's not quite straight. I'm sorry about that. It's a little better. This graph, this line, is all of the possible answers to this. Oh, well, if x is 0, then y is 8. If x is negative 1, then y is 1. If x is negative 2, then y is negative 6. Are we okay? All right, good. All right, so, but we have to understand, how does this relationship come about? How do we understand the pieces of this relationship? So this whole relationship is based off of only two numbers, which we've already discussed, m and b, correct? Okay, so in the formula, the y is always a y, the x is always an x. It's the m and the b that we have to try and figure out. Okay, so what is m? What do we call m? M is the slope, right? M is the slope, okay? And how do we calculate m? Rise over run, okay? Rise over run. You're going to want to write all of these down. M is the slope. Slope is rise over run. Rise is change in x, or we use the Greek letter delta, which looks like a triangle, equilateral triangle. Delta y over delta x. Delta, the Greek letter delta, is often used to indicate the word change. Okay? The rise is the change in y. Because look, isn't change in y, doesn't it go vertical? That's the rise. Now here's the problem. Sometimes the rise goes down. That's a negative rise. That's when your change in y is a negative value. Okay? Over the run, change in x. Now usually the run goes forward, usually. But you can go backwards. You can do negative run and negative rise, or negative run and positive rise. It's fine. You can go forward or backwards, up or down. You're going from one point on the graph to another point on the graph. That's how you find the slope, right? And the way that we calculate the slope, the way we calculate change in y over change in x, is y sub 2, which we just say y2 minus y1 over x2 minus x1, where x1 comma y1 is a coordinate and x2 comma y2 is another coordinate. Okay? Does this sound familiar? You guys remember this? Okay, good. So here's what will happen. You might be given 2 points and you might be told, hey, what is this? There's a line. There's a line that passes through these 2 points. 7, 6 and negative 2, 7. What is the slope of that line? Go ahead and try it. Here's what you got. This is x1, and this is x1. You know why this one is x1? Does anyone know why this is x1? Say it again. Yeah, this one is a smaller number than this. Whichever x, you always start with the x. It doesn't really matter, but whichever x is the smaller x is the x1. And the y1 is not the smaller y. The y1 is the y value that goes with the x1. So here's what we have. We've got x1, y1, and x2, y2. This is not a 1/2. That's a y. Say again. Say it one more time.
9 over 1. Or 1 over 9.
Oh, I see what you're saying. Yeah. So how do we calculate this? Well, you guys go ahead and do it. Go ahead and calculate it. Write it out. Use this formula. The slope formula is y2 minus y1 over x2 minus x1. If you can understand that, we can then go to the next step. And I think you do understand it. I just want to make sure here. So here the slope would be, okay, y2 is 6, y1 is 7, over x2 is 7, and x1 is -2. Go. And what's 6 minus 7? And what's 7 minus -2? And so the slope is -1/9. Okay? Now, do you want to do another one, or do you want to move on? If any one person wants to do another one, I'm doing another one. Does anyone want me to do another one? You want to do another one? All right. So what is the slope between the points 0, 12, and 9, 20? What is the slope between the points 0, 12, and 9, 20? If you were to graph 0, 12, and 9, 20, 0, 12 is about here, 9, 20 is probably right about there. 9, 20, 12, and then of course the y-axis is 0, right? You keep working, but I do want to ask a question. Which one is x1? Whichever one is the smaller. So 0 is small. Now, Anna, I'm going to be honest with you. It doesn't matter. Did you know that you can find the same slope by doing y1 minus y2 over x1 minus x2 as long as the coordinate pairs are on top of each other? As long as you don't put this one over here and this one over here, right, to where you have y2 and x1 here, then it's going to work out. All right, so x1 is the 0. That makes x2 the 9. Which one's y1? The 12. And which one's y2? The 20, y2. So now we're going to do y2, 20, minus y1, 12, over x2, 9, minus x1, 0. What do we get? It's not negative, though. Look, we're doing 20 minus 12. Yep. You want to make sure that you are... Now, here's the thing. Here's what you need to be noticing. You need to notice that this is one of your coordinates on top of each other, and this is your other coordinate on top of each other. You would get the same answer if you did 12 minus 20 over 0 minus 9. They would just both be negative numbers, and then they would cancel to a positive. So 8 over 9 is your slope. So the slope of this line right here, 8 over 9. Okay? Should we do a third one? We're okay? We all right? What's that? You good? All right. So let me show you something here. Well, let me wait to get that. Let's go over to our slope formula here. You have to watch what I'm about to do. Did you have your hand up? Oh, you were, sorry. Okay. You have to watch what I'm about to do. Please be looking up here. It's really important that you watch this. I'm going to wait for everybody. All right. All right. Danielle, you okay? You ready? I want you to see this. I'm going to do something algebraic here. Okay? What I'm going to do is I'm going to cancel the denominator. How do I cancel this denominator? How can I cancel this denominator? Well, I can't add or subtract. Multiply by itself. Multiply by the denominator. Do you guys remember that? Right? That the way we cancel a denominator is by multiplying by the denominator. But the denominator is not either one of these. The denominator is the whole thing. Is that what you said before? You said something else, right? It's all right. Parenthesis. X2 minus x1. Right? And then I can cross that. But because I'm multiplying this side by x2 minus x1, I got to multiply x2 minus x1 on this side, right? All right, so here we go. I'm going to cancel the denominator. Yep. x2 minus x1 times m equals y2 minus y1. Now, did you guys know that, you can flip equations around and it still stays the same? Right? It's an equals, right? So I can put this on this side and I can put this on this side. Is that okay? All right. So y2 minus y1 equals x2 minus... I'm going to do that in just a minute. Times m, right? Did you also know that multiplication is commutative? The word commutative means it doesn't matter in what order you do it. So 2 times 3 is the same as 3 times 2, correct? So is it okay? Would this be the same if I put the m on the other side? Is that all right? So now I have y2 minus y1 equals m times x2 minus x1. Do you know what you're looking at right there? Does that look familiar? We talked about it last week. It's okay if you don't recognize it. We only talked about it one time. That's the point-slope form of a line. That's the point-slope form of a line. And if you put a number in for y1 and x1, or a number in for y1 and another number in for x1, you will have the equation of a line. Well, do we have a y1 and an x1? How about here? Right? Do you guys see this? So if we put negative 2 in for x and 7 in for y, here's what we'll have. y2 minus 7 equals. What's the slope? What did we determine the slope was? Negative 1 over 9. Negative 1 over 9. Times x2, it's negative 2, right? What does minus negative 2 mean? Plus 2, right? And now, here's the cool thing. Because there's only one x and one y, we don't need these subscripts. And guess what we have here? You know what this is? This is the point-slope form of the line that passes through these 2 points. Okay? I want to do another one of those. Can I erase this over here? I also want to erase... Can I erase... Well, let me just erase this for now. Can I erase the definition of slope here? All right, good. And also I'm going to erase these two. Okay. Can I erase just this part right here? All right. Here's what I want to do. I want to give you a problem. I want you guys to work on this. Here's what I want to do. Three, negative 1, and 5, 7. Here's what I want you to do. On your own, quietly, and over about 3 minutes, I want you to identify so there's a line that passes through these 2 points. We're going to say line 1 passes through these 2 points. And I want to know what the equation of the line is in point-slope form. Okay? Go. What should we call x1 here? x1? And that makes this y1, x2, and y2, correct? Right? Each one of these is an x, y coordinate. And so to find the slope, slope will be y2, 7, minus y1, negative 1, over x2, 5, minus x1, 3, right? And so 7 minus negative 1 is 8, and 5 minus 3 is 2, making the slope 4. Okay? All right, so we got a slope of 4. Now, we're going to take this form here. Wait, we're going to take this form right here, y minus y1, y minus a y equals slope times x minus an x. So it's going to be y minus, I'm going to pick this one first, okay? Y minus negative 1. What would y, and it's got to be the y value, so it's got to be negative 1. What would y minus negative 1 be? Y plus 1, that's right, equals the slope 4, parenthesis, times x, go ahead, x minus 3, because it's got to be minus the x that comes from the same coordinate, x minus 3, and there's one possible answer for point slope form. Now you could have instead used 5, 7, in which case you would do y minus which number? 5 or 7? Would I put a 5 or a 7 here? A 7, because it's got to be the y coordinate, right? Y minus 7 equals 4 times x minus what? 5. And so both of these are the same line. You want to prove they're the same line? Let's do this. Half of you, let's say over here at that table, can you please take this equation and solve for y? Okay, solve for y. It's going to have an x in it. You're not going to get a final number, but solve for y. Everyone at this table, take this one and solve for y. Solve for y in both of these. Okay, one of them is going to be y plus 1 equals 4 times x minus 3. The other one is going to be y minus 7 equals 4 times x. Oh, I don't think the video can see this one. Let me put it a little closer. Y equals, y minus 7 equals 4 times x minus 5. Hope it can see that. All right, let's go ahead and do these. There's a couple ways to do this. Maybe, did y'all distribute first? Okay, so you had y plus 1 equals 4x minus 12. Does that look right? And then you just subtracted 1 from both sides? And so you had y equals 4x minus 13. Now you guys should have gotten y equals 4x minus 13, but let's see. Maybe I made an error somewhere. If we distribute here first, we get y minus 7 equals 4x minus 20. Then if I add 7 to both sides, I get y equals 4x minus 13, which is the same. Hey, those are Miami Dolphin colors. I grew up in Florida. Miami Dolphins are a big deal. What's that? A little bit? Yeah. All right, so as you can see, it's easy to get y equals mx plus b form from point slope form. And so what I recommend for you is that whenever you're doing point slope form or slope-intercept form, here's what you do. First, if you have 2 points, if you're given 2 points, okay, step 1, find the slope, y2 minus y1 over x2 minus x1. Step 2, take one of your points and your slope and put it into a point slope form. And then step 3, convert to y equals mx plus b form. And then you have all of the information that you will ever need about this line. If you are only given, if all they give you are 2 points, and they say, hey, there's a line that runs through these 2 points, okay? Man, that brown marker is strong. That there's a line that runs through these 2 points. What is the equation of the line? And what if they say, what is the equation of the line in y equals mx plus b form? Well, your first step, your very first step is to try and identify what the slope is. Just take your 2, look at this. I want to show you guys something. Take your 2 points. Let's say one of the points is 1, 5, okay? And let's say that the other point is 4, 12. Okay? You could visualize it like this in your mind. Watch what I'm going to do. See this 1, 5? I'm going to turn it counterclockwise so that the 1 is down here and the 5 is up here. Got it? I know it's a little weird. Just hang on. I'm going to turn this one also counterclockwise so that the 4 is down here and the 12 is here. Do you see that? I've got them turned. Y'all see them? 90-degree angle, right? Okay. Okay? Well, watch this now, what I'm going to do. I'm going to put a fraction line in here, and I'm going to put in some subtraction symbols. You see it?
Yeah.
And now it's 5 minus, and on the bottom, 1 minus, okay, 5 minus 12, and 1 minus 4. Okay, and now listen, I know what you're thinking. Hang on, I didn't do y2 minus y1. Should I back this up, or do you want me to just continue? All right, because look, I'm going to show you that it doesn't matter whether you do the first ones minus the second ones or the second ones minus the first ones. Because what this is going to wind up becoming is, get a black marker. Where's my black marker? Can't find there it is. My favorite black marker. Okay, so look. 5 minus 12 is negative 7. And 1 minus 4 is negative 3. Well, what are these two negatives going to do? Yeah, they're going to cancel each other out, right? And so now the answer is 7/3. And if we had done 12 minus 5, we would have had 7. And if we had done 4 minus 1, we would have had 3, which is 7/3. Shamar, did that help a little bit? All right, so your first step, the very first thing that you want to do with the 2 points is find the slope. Once you have the slope, okay, that slope goes now into the point slope form where the m goes. Right? And one of your points, look at this. Let's say your x2 is going to go there. And it can be x1 or x. As long as it's coming from the same point. And then we put the y2 there. You just take one vertical. Either take the green ones or take the orange ones and put them here and here. And now you have point slope form. And then if you do this algebra over here, you'll get mx plus b form. Does that make sense? And I will, on the test, actually our first quiz is going to be Tuesday. I need to warn you about that. Our first quiz is going to be on Tuesday. All right? So the next time I see you at the beginning of class, I'm going to give you a quiz. One of the things I'm probably going to have you do on that quiz is I'll just give you one pair of points, and I'll say, identify the slope, give me the equation of the line in point slope form, and in mx plus b form. Okay? So now that we know how to identify slope and we know how to identify, now what we got to identify the equation of a line. Now what I want to talk about is we're going to do 2 more things. We're going to graph, and I want to talk about parallel and perpendicular lines. Parallel, let's talk about that first. Parallel and perpendicular lines. All right, I want to show you something. I'm going to pull up a Desmos page here. If you've never used Desmos, it's pretty awesome. So watch this. I'm going to put in 2 lines in here. Let's say I have y equals 2x minus 3. So this is the line y equals 2x minus 3. Now, how can I know? If I look at this graph, one of the things you're going to do in your homework is you have to be able to look at a graph and you have to be able to identify the equation of the line in slope-intercept form based on just looking at the graph. So, how do you think, how could we start to know what the equation is here? We know it's y equals mx plus b. We know it's going to be y equals mx plus b form. Let me write that over here. So if we're going to write this in y equals mx plus b, we need 2 things. We need the b and we need the m.
B is whatever the y-intercepts are.
Correct. You want to always just go straight to the y-axis. So go to the origin and either go up or down, whichever direction the line is. Okay, this red line, the line you're trying to figure out. And if we count down, how far down are we going to count? 1, 2, 3. So what does that mean the y-intercept is? It's -3. So we know that this is going to be y equals mx minus 3, right? How do we find out what the slope is? Rise over run. Now here's what I recommend. What I do is this, I always follow the line until I get to another cross intersection. So is this a cross intersection? No. How about this? Yes. Okay, so now I have 2 cross intersections right here. And what I'm going to do is I'm going to count either up and over or down and over. If I count up and over, what kind of slope is that? That's a positive slope. If I count down and over, what kind of slope is that? Negative. So how far up and over am I going to count? 1, 2, and then over. So the slope of this is 2, right? 2 over 1, which is 2. So the equation of this line is y equals 2x minus 3. All right, now I'm going to put another one up here. All right, check this out. Can you everybody try and identify the equation of that blue line right there? Do we have a y-intercept for that line? It's 5, plus 5, right? So it's going to be y equals something x plus 5, right? All right, what's the slope?
-1 over 2.
-1 over 2? Is that what you guys got? Okay, it's negative because in order to go from one place to another, we have to go down and over. Yeah. Right. Usually we read from left to right. Now, from left to right, is this line going uphill or downhill? Uphill. That means it's a positive slope. From left to right, is that one going uphill or downhill? Downhill. That makes it a negative slope. Does that make sense? All right, good. So does everybody agree -1/2? Right? So this one is y equals -1/2. We're going to do one more. One more line, okay? Let me freeze this, okay? The green one. Can you identify the equation of the green one? What's the y-intercept? 2, positive 2. So there's an x there. What's the slope? -1/2. All right, let's check it out. Got here, another intersection is here, or let's go all the way over here, right? Let's go all the way over here. Down how far? 2, how far over? 2 over 4. -2 over 4 is -1/2, right?
Yeah.
Yep, there we go. All right, does anybody notice anything interesting about these lines?
They're different colors.
They are different colors.
They all cross each other.
Okay, these two cross this one, right? Okay, how about these 2 lines? They're parallel. And there's more to it. Not only are these 2 lines parallel, but the red line and the green line they make a 90-degree angle. They are perpendicular. Also, the red line and the blue line are perpendicular. And go ahead.
Sorry, what was the equation of the red line?
It was, it's up there. 2x minus 3. So here's what we have. Let me mute this. Let me mute the video. Okay? And let me pull this up. Now, look at these three equations. Everybody look at these three equations. Now, these two lines were parallel. These two lines were perpendicular, and these two lines were perpendicular. Now, don't say anything. I want you to think for a full minute, and I want you to try and figure out if you can. You may already know the answer to this. That's fine. Okay? But I want you to take a minute. Don't say anything to anybody, and I want to see if you can figure out how we can define parallel and perpendicular lines on a graph. Go. I said, looking at these, is there a way just by looking at the equations of lines that we can figure out? You think you figured it out, Alexandra? Well, yeah, don't tell me yet. But yeah, okay, so you think you figured out parallel? Is there a way that we can just look at two equations and tell immediately whether they are parallel or perpendicular? Okay? Here's the truth. In the universal two-dimensional coordinate plane, any two lines will intersect except lines that are parallel. The only lines that don't ever intersect are parallel lines. Other than that, all other lines intersect. So the definition of a perpendicular line isn't two lines that intersect. Perpendicular lines intersect in a very special way. How do perpendicular lines intersect? What's that? At a 90-degree angle. Are you aware of that? Okay, so lines that are perpendicular, they intersect at a 90-degree angle. They make a right angle. That's the definition of perpendicular lines. Okay? All right, Alexandra, how would you know without seeing a graph, without seeing an image, how would you know whether two lines are parallel? They have the same slope. Lines that have the same slope are always parallel. And it doesn't matter whether they are in point slope form or slope-intercept form. If you have two lines and one's in point slope form and one's in slope-intercept form, but they have the same slope, they're still parallel. So what do you think perpendicular means? Leah, you thought maybe you knew what does perpendicular mean? Or how can we know whether two lines are perpendicular? We already know that this is perpendicular to this.
I just noticed that the slope is the reciprocal of the other one.
Not just the reciprocal. There we go. Perpendicular lines have negative reciprocal slopes. Negative reciprocal slopes. So, if I had a line, let's say I had a line y equals 4x minus 12, or let's say I don't like being able to factor stuff out. 4x minus 13. Okay? And then I have another line, y equals something x plus 1. To make sure that this line is perpendicular, what should the slope be? 1/4? Very close. What did I say the perpendicular means? Negative reciprocal. So it would be negative 1/4. So the line negative 1/4 x plus 1 is perpendicular to the line 4x minus 13. We okay? All right. Let's do another one like that. Well, how about this? Let's say that we have the point 4, 6 and the point 5, 11. Here's what I want you to do. I want you to write the equation of this line in point-slope form and in y-intercept form, or slope-intercept form. And then I want you to write the equation of a line. You ready for this? I want you to write the equation of a line that is perpendicular to this line and passes through the point 7, 10. Try that. Start out with the first step. You're doing your 1, 2, 3 step. You're going to identify the slope, then put it in point-slope form. Okay, first, once you have the slope here, put it in point-slope form. Remember how to put it in point-slope form? Let me write that down again. The point-slope form is y minus y1, where y1 is a number, equals m times x minus x1.
And then you want us to put it in the
Point-slope form, then slope-intercept form, then identify a line that is perpendicular to that line. Perpendicular to that line. And passes through the point 7, 10. And the best way to do that would be to use point-slope form. By the way, if I have a line y equals 7 over 3x plus 6, can you give me a line that is perpendicular to this? Perpendicular to this line. Negative 3/7. Yep, x, and then it doesn't matter. Give me any number. How about plus 1,000? There we go. Perpendicular. This does not matter. The only thing that matters is that how many lines in the universe are perpendicular to this line? Say again? A lot. How about an infinite number? Right? If I have this line, isn't this line perpendicular? And how about this one? 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 Right? How many lines could I possibly draw that are perpendicular to this line? An infinite number. Right? It's only the slope that matters. That's right. It's only the slope that matters.
somehow you switched it from the y equals and it's supposed to be a perpendicular form.
Oh yeah, it's not perpendicular form. We don't really call it that. I'm just saying that that anything with a slope of negative 3/7 is perpendicular to the line that has a slope of 7/3. All I'm trying to get you to understand is the very simple idea that perpendicular lines have negative reciprocal slopes. That's it. Perpendicular lines have negative reciprocal slopes. Okay, so what did you do on this one? What's the first thing you did here? What's the first thing you did here? Found the slope. How did you find the slope? M equals what? 11? Give me the formula. 11 minus 6 over 5 minus 4, right? Yeah. Please make sure you are practicing this. Man, if I were you, I would just invent 2 points and find the slope between them. Invent 2 points. Just make up any 2 pairs of numbers and find the slope between them. And all you're doing is a y minus a y divided by an x minus an x. That's it. 11 minus 6 over 5 minus 4, right? So 11 minus 6, well, that's 5. 5 minus 4 is 1, so what's the slope? 5. So let's put it in point-slope form. Help me out. Y minus 6 equals 5 times x minus 4. Yeah, x minus 4, right? We would only change it to a plus if it was a negative coordinate, right? All right, now let's turn it into slope-intercept form. How do I do that? What am I going to do? Distribute, okay? Y minus 6 equals 5x minus 20. Now what? Add 6 to both sides, and I get y equals 5x minus 14. So here's my slope-intercept form. Here's my point slope form. My point slope form. Lastly, the equation of a line that passes through the point 710 and is perpendicular to this line. So what form should I use? Slope-intercept. So how does that go? Y minus 10 equals, let's skip, what did you say? Negative 1/5, right? Because it's the negative reciprocal of this one, right? This has a slope of 5. Negative reciprocal of 5 is negative 1/5. And then what? X minus 7. There we go. There's the equation of a line that is perpendicular and passes through the point 710. You okay, Abby? Okay. Spirit, are you asking me about this right here? Yeah. Okay, so we used point slope form because once we have the slope of this line, won't that tell us the slope of the perpendicular line? So if the slope of this line is 5, then what's the slope of the perpendicular line? Negative 1/5. Now that we have a slope, well, they gave us a point, right? So can't we just plug that point in here and here? Yeah, did you write it in slope-intercept form? All right, that's fine. Did you already do it? I'm saying you don't have to, but okay. Y minus 10 equals negative 1/5 x plus 7 over 5. And now let's add 10 to both sides. Now if I'm adding 10, I'm actually not going to add 10. I'm going to add 50 over 5. Cancel 10 on this side, and I get y equals negative 1/5 x, and then 7 over 5 plus 50 over 5 is, plus 57 over 5. But I didn't say you had to put it in this one in slope-intercept. I want to do another one like that. Okay? Can I? No, not this. Don't copy this. Oh wait, hang on. Let me put back what you just want to copy this down. That's it, okay? So, Jenny, basically what we learned is that if you want to know whether two lines are parallel or perpendicular, parallel lines, here, I'll write it right here. Parallel lines have the same slope. The same m, right? Perpendicular lines have negative reciprocal slopes. So, if a line has a slope of 7/5, what would the slope of any perpendicular line be? Negative 5/7. There we go. These would be, if these are slopes, these are slopes of perpendicular lines. Okay? All right. Let's do one more of these. I want to do another one of these. All right. How about we've got the, there's a line that passes through the points -4 and 0 and the point 6 and 13. Actually, no, not 613, sorry. We're going to make it 612. Here's what I want you to do. I want you to find the slope. put it in point slope form. Point slope form. 3, put it in slope intercept form. And then 4, I want you to identify a line that is perpendicular to this line and passes through the point 1, 5. Passes through the point 1, 5. Okay? Why don't you take about 3 or 4 minutes, and then I'll work through it, and then we'll be done. We could say that this one is x1, and that this is y1, and that this is x2, and this is y2. Although, like I said, it doesn't really matter which one is x1 and which one is x2. So if you want to calculate the slope, it's going to be 12 minus 0 over 6 minus negative 4. Mr. Ryan messed up the first time he cut it out. 12 over 10. Spirit, is this more like what you got? Okay, very good. Thank you. Which is actually equal to 6 over 5. All right. Sorry about that, guys. And then if we want to do point slope form, which point do you guys want to do? Can we do the one that doesn't have a 0 so that we have a number in there? You already did the one with the 0, which is okay. It's all right if you did the 0. All right, well, let's do the 6 and the 12. How about y minus 12 equals 6 over 5 times x minus 6, right? Which can get a little messy because when we want to turn it into slope-intercept, we're going to have y minus 12 equals 6/5 x minus 36 over 5, right? Because 6 times negative 6 is negative 36, right? A little messy. We're going to add 12 to both sides, but on this side, it's got to be over 5. And so I got to do 12 times 5, which is 60. So on this side, I'm actually going to add 60 over 5, because that's the same as 12. And that's going to cancel, and then I'm going to have y equals 6 over 5x, and then I got negative 36 and positive 60, which should be 24, thank you, plus, go ahead, Danielle, 24 over 5.
It says y minus y1. But for when you put for point slope, you said y minus 12, but you have 12 as y2.
Yeah, what I'm saying about this is the formula for point slope, but honestly, you can put any xy coordinate in here. It doesn't have to be what you have designated as x1 and y1. It can be any coordinate on that line, right? And now, what is the perpendicular slope? Negative 5 over 6. So now I just need any line. It passes through the point 1, 5. So I'm going to do point slope form. So what am I going to write? Y point slope form minus 5 equals negative 5 over 6, which is the perpendicular slope, times x minus 1. Right? And there we go. Perpendicular line that passes through the point 1, 5. That's it. Now, let me explain the worksheet that I'm giving you. Actually, I'm going to leave this on the video. So I'm about to give you, it's one page, and here's what you're going to do on this one page. Is on the top, there's 6 questions where I give you a graph of a line. I want you to write the equation of the line. Now, yeah. Now, you can do it in point slope form, or you can do it in slope intercept form. It doesn't matter to me. Okay? Either way, it will be fine. Point slope form is usually easier. Or not point slope form. Slope intercept form is usually easier when coming from a graph. Now here, these middle 6 questions, are exactly like what we just did. I give you 2 points, and I want you to write the equation in point-slope form and slope-intercept form. Okay? But I didn't ask you to give me a perpendicular line. Here, there's only 3 questions, 3 pairs of lines. And all I want you to do on these 3 questions is tell me whether those 2 lines are perpendicular, parallel, or neither. Okay? Last thing, down here there's 6 blank graphs with equations under them, or functions under them. I want you to draw, oh, I missed a parenthesis there. Again, keep missing parentheses. Something wrong. What's that? That's it. Yep. So on these 6 down here, I want you to draw the line. Use a ruler. Okay, I want you to draw the line. Use a ruler or a straight edge because I want it to be a straight line. Okay.